aesthetically pleasing prototype with the 5 channels. The whole thing has 42, but we just need 5 to work before I could start pitching this for some funding, some capital, good old capital. So yeah, I gotta pull all this out. I gotta take this. I already did a lot of the work. I took the heart, or the brain, the microcontroller. I was using an ESP 32C6 Pico by Waveshare, and it's cool because it has like the GPIO extender, so it gives you some extension, but it doesn't. I needed more like analog pins and ADCs, and so this just wasn't gonna cut it. You know, and I've gotten more comfortable in the STM32 family, which is way more capable and gives us a lot more GPIO pins, and it gives us a lot more of everything. But now the only thing this has is it has the wireless, has Wi-Fi, Bluetooth, all that. So I might still use this as a coprocessor, but like in the main build, which I'll have like OTA stuff going on, but not with the prototype. I just need it to work. Okay, so we moved for the prototype, we use an STM32, and this is an H7, and it's got way more pins, way more capable pins. So now I do have like the single channel one or whatnot, like where one works. Let's see, see if I could. Oh no, this cable. Did I just unplug it? I don't think I did. So let's see here. There we go. See, so it works. It's oh no, did I unplug it? What did I just do? Okay, did I just hit something? Oh. See, that's the problem. Dang, what the? Oh, I did. I unplugged it. 1 second. Okay. I don't even know why I'm showing you this, because it's not like I'm going to be using it, but every time I try to show somebody this, it ends up not working. Now what? Oh, great. Now it's not even turning on. Well, we don't need you anyways, but what's going on here? Shouldn't this just go to ground? Oh no, that goes to an actual pin. Hold on. Oh, it's the cable, isn't it? Yep. Okay, so now I gotta, hold on real quick now. There we go. So, alright, that. So now I can hold that down. Yep. And then I can move. I don't know. You could kind of see it. I mean, so let me get this. My eyes are terrible. So, oh, okay, here we go. It's upside down, but you could see it works, and I could change it. So we got like agriculture, and hold on. So then I can switch it to like corruption. So then we got corruption, but the problem is that one doesn't have the motors on it anymore, because let me get a focus here. Okay, so this one has the motors in it, and these motors are like $50 each. So yeah, I don't have these to really spare. Now I got lucky and got all of these. I don't know who was selling these, but they sold all 5 of these for $50. So I got each one for $10. Right now the cheapest one that I can find is like $30, but it's not the same company. It's like RY. It's like RY. It's an Alps. That's who makes the ALPS. But so anyway, so what are we doing today? I need to replan everything. So I did this wrong. I rushed into it, and let me get that out of here. So that's what we're gonna do. We're gonna go through this, and I'm gonna do this the right way, and not just plug stuff in. I'm gonna have to take all this out, but for right now, what we're gonna do is we're gonna plan, especially power distribution. So let's do that. Now I haven't really thought of the best way to go about that. So here we are. This is Cube MX, and you can see I already kind of assigned a lot of the pins for the STM32, and it's great because I have a lot of ADC channels, and I haven't even used like half of them. You know, so these are the actual sliders pins that'll connect to the potentiometers that the motors are driving. Let's see, what do we want to do? I'm trying to think of what software we can do this in, but you know, we can do Easy EDA. You know what? Maybe we shouldn't do this. Motor driver. Yeah, and I even had to design this whole circuit board here for the old one. I don't need this now, because now it's built in, but I had to build this to work with the ESP32. And I was pretty happy about this, but you know, it was just unnecessary. Just an unnecessary piece of building. But I did get to use these really cool SMT, these little tiny little relays right here. Those are pretty cool. So yeah, I was proud of this one. It was ready to get manufactured, but money is of the essence. So let's do this. Let's say we'll do new board. Okay, we're going to call this one Proto V2.1. Where'd you go? Okay, and here's prototype. I'm gonna just call it prototype. Okay, let's just get this. Prototype. We'll call it a V2.1 right here too. Okay. This is why I don't know if it's going to be the. I don't even know if I can do modules on here. Can I? Sorry. TP 612 FNG. There's the actual chip. you can't even see it because I'm over there. So what I'm going to do is put myself over there. Okay, so I'm looking down here. How are we going to do this? Oh no. Cancel. I don't want that. I want obsidian. Okay. Okay. So this was pretty much on the main board. Let's create a new canvas here. And we will call this one prototype, right? And we'll take from this. Let's grab let's grab a part here. And we want a motor slider. Let's see. We want to grab the right one. Huh. Now we want to say, here we go. Fader. Let's grab the right one. Here we go. MFT. Yep. This is it right here. You can see $55. You know, getting them used is not much of a deal. So can we get to? I know I have the data sheet somewhere. Where would I have saved his society? Do you see data sheet? Look for data sheet. Oh yeah, on tools, resources, data sheet. There we go. Here we go. Okay, this is it. So we have the 2 motor pins, of course, and then we have the track, wiper 2, 1. So I usually have how do I do this? So I have see if I can find this part. LCSC. Not available, but that's a good sign, which means if I do this, that means, aha! Okay, so that means I can throw 1, 2, 3, 4, 5. And that also means I can hit this. Yeah. Okay, that was a lot easier. I thought I was going to have to make one of these. Let's see. It even got the model. Whoa. Whoa. Okay, that helped me out a lot. Okay, so we got those. Okay. Now I'm using these modules. Let's just put jumpers. We're just going to use jumpers for them. So, jumper. Jumper wire. Actually, no, we want to call it. We really just went through holes, right? Okay, so we got one of these. Also got one of one of these. Okay. Okay. So I got the motor driver. The same kind. Looks kind of big. Okay, anyways. So we got the I2C extender. Then I'll just open up a new one of these just so I can get the dimensions. Alright, I'm going to guess it's a 2.5. Zero that out. Huh. Is that... It's a 1 millimeter pitch. Yeah, okay. Not 2.54, not pretty standard. Let me see here. Put this up to a standard one. Yeah. Okay, so that's 1 millimeter. 1 millimeter, we'll call them headers. Would that be the right? Pitch. Go through the data sheet. See, these say 2.54. But I'm just not... units. That almost caught me there. Let's try that again. Yeah, okay. See, I was surprised. I was like, that's crazy. Okay, I was in inches, so Whoops. So that makes sense. 100 mils. That's what I was seeing. I was seeing 100 mils. All right. So let's see. These are pretty cool. Wait, what are these? Through hole round pins. Let's see. Why wouldn't I use these? I could just solder it directly to it. I guess that kind of defeats the purpose though, right? Yeah. Alright, so let's go back out. We want females. Header. We want 2.54 female. Okay, we want 1, 2, 3, 4, 5, 6, 7, 8. 2 by 8. 8B. Why is this so hard? I mean, we could just do this. We'll just do this. We'll just make it. Okay. So I want to. Female headers. Get rid of that. Oh. Nothing? Oh, we're loading. We're loading. No data. Come on. Give me something. Ooh, okay, here we go. If I can't find these, I'm just going to... Okay. That's sort of what I want. Let's see, okay. Let's see, female receptors, female sockets. Here we go. We want 8. Can we, whole structure. You want 8. No, that's 2 by, no. Okay. Clear that. Apply. we want one by 8. Can we find a 1 by 8? That's what we want. That's got to be it right there. Yeah, that's it. Yeah. So we'll get that. Copy. So we're gonna and let's create a new no, it's gonna be too much work. Okay, so what we'll do is we'll flip these. We'll put these guys like that. Can we flip? Alright, whatever. That and that. Let's align to the top. Yep, okay. So we'll put them like so I think how these are going to be. We're going to call that one VM. Oh crap. Can I do multiple? Or is it? I don't think I can do multiple in this. I can do it when I'm running traces, but I can't do it in the schematics. All right. This one is VCC. This one. And this one's going to be called, that's a ground. Then we get AO1. Alright, I'll arrange the words in a second. AO2. BO2. BO1. And then ground. PWMB. Is that ground? Yep, ground. Okay. So now I can just select all of these. Just move all of these. Boom. Okay. All right. PCC goes down like that. Now this gets a little difficult. Let's see if we can get a good standard distance. Looks like 15 millimeters. So that means we want to go, we want, God, dang it. Okay, hold on. Distribute. Oh shoot, I forgot what the offset is here. Hold on, we can do this. We can just, we'll align. Alright, and then this one. Top. Now let's remeasure that from there to there. And let's see, millimeter 15. All right, there we go. So we just need to copy that 3 times. So we, and that, we're going to group them. So group selected, that's going to be the TB6612FNG. So Now if I move it, they move together. All right. All right, it's changed the names. We got to change more names, don't we? Okay. So some of the names, not all of them. So VM, VCC, those are fine, but these data pins, these all need to change. And then all those, okay. Let's get to it. Okay. So we'll call this driver 1. Okay, wait, let's see how do I name it in here? Yep, I just called them D1, D2. And, okay, and now for these, actually, this I actually need to get the pin out. Okay, right here. Driver 1, PWMA. Driver 1, PWMA. Driver 1, AN2. Driver 1, AN2. Driver 1, AN1. Driver 1, AN1. Standby. I think I have them all on the same standby pin anyways, but we'll still P5. Driver 1, BN1. BN1. Right, B2. There we go. PWMB. PWMA. Driver 2. A2. Driver 2. A1. Driver 2. Standby. D2. B1. B1 right here. B2. Driver 2. PMW. PWM. Sorry, B. Okay. PWMA. Driver 3. A and 2. Driver 3, A and 1. Driver 3, standby. Alright. I know, so we got to do this. We got to do our SDA pin for the I2C, SDA, 87, and then SCL. Alright, and then reset. We actually have a reset pin now. PB8, okay. And that should be good. So we actually need to change some of these. OLED, SDA, oops. SCL, SDA, SCL. This SCL, SDA, SCL, SCL and SDA. Okay. So these pins are good. These pins are good. COM. Oh, communications. Okay, if these are for general purpose debugging. I also need SWDIO and SWCLK, right? Which I know I got them. Let's see. Got I2C, trace and debug. So SWDIO is PA13. PA13 and PA14. Easy enough. Okay. And these will be called debugs. Okay. Debug. SWCLK. Debug. Okay. Alright, well, I'm gonna have to fast forward this because this is going to take way longer than I was thinking. Okay, so we want this to go to motor 1. And how did I do this? So A1 is M1 positive, which this would be M1 negative. Okay. So driver 3 is actually what has 1 on it. So it goes down. We're counting down. Okay. Which I'm redoing all this, so maybe it's not. Yeah, you know what? We're taking all this apart, right? We're doing it the right way. 3, 4, 4, 5, 5. So we have spaces, don't we? Yep. It's 5 plus. Do we need this space? No, we don't need the space. Whoa. Slider 3. Slider. You know, saying slider is probably not the best way, but it does make a little sense, but at the same time, it's not the slider, it's the motor on the slider. But, you know, whatever. Alright. Alright. So you get M1, M2. M2 negative, M2 positive, M3 positive, M3 negative, M4 negative, wait, yeah, okay, yeah, M4 positive. Okay, now we need, these are actually not used. Then here we got M5 positive, M5 negative. Okay. Okay. So we got P3, P4, P5, and P6. How do I do it here? 1, 2, yep. Let's do it like this. That one and that one align top. Let's just make sure we have that one 590, which yeah, that's correct. 15 millimeters, yep. So now we got these. Those are grouped under that. We'll call this one driver 1. Driver 1. Yep, so now these driver 2. Yep, driver 2. So now with this one, we want this one to align to the right. With this one, we want this one to align to the left. We want this one. We want these align to the top. We'll select them. There we go. So we'll put these like that, sort of. And let's take a look at it. All right. So that's those done. Routing is going to be a bitch. I'm hoping that I can do this all in 4 layers. I think I can. It's not crazy complicated. It's just a lot of crap. Okay. We also need the PCA. See what the dimensions are of this guy. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 by 2. So that's 8. So now we need 1 by 12. What was the company? This is Boomel. Boomel. Let's see what the price is. 68 cents. Okay. We'll do that one. Single row, 3 amps. Okay, yeah, we're good. 5.54. Oh, actually, you know what? We also want to open up this one. Three amps. Okay, we're good on that. That one, and then next, this one we just need 2 of them. Bring it down. Okay, so. Okay. Quite a few of these. the line. The in. A2 STO. Oh, hold on. Nope, nope, nope. It's not a no. It's a 0. We got SC7, SD7, C6, SD6. SC4. Guess what? SD4. C3. SD3. Oh, what the hell? 77665544. Oh, okay. Can I select all of these? Like, nope. You know what? Yep, yep. Whew, okay. Are these still grouped? No, they're not grouped on here. You know what? It's really not that important. What I could do is I could just do this. That's what I should have done. God damn it. Next, I'm just going to do this, and then I'll get to the rest later, because I've already done a lot. Let's see, 6. Alright, so let's line these up. Alignment, top. I'm seeing 18. I'm seeing more of like a 17 and a half. Anything, but I think I'm gonna do 18. Yeah, we're gonna do 18 millimeters. So millimeters, let's do 18. Alignment, top. Let's try that again. There. To there. 18, all right. Then we'll group them together. ECA 9548A. We're actually going to want to isolate these away from the digital stuff, so in a way we'll put these like that. Oh yeah, another thing is we'll align these to the right, then we'll distribute them vertically. Oh, there we go. I think I have them a little bit closer together. Something like that. very close together. To the right. We'll try that again. Distribute vertically. There we go. Alignment to the right and distribute vertically. Now the I squared C is going to go somewhere right there because on the screens, oh actually I kind of want to put it like right down here. So essentially the board outline can be something like that. Let's see, what are we looking at? I've never made a board this big before. It's 9 inches. I really want to keep it under maybe let's check this out. Seven. Seven and 3/4. It's really what I want. 7 and 3/4. So let's do this. Let's do 7.75. Wait a second. Okay, let's do 8. We'll do 8. I can push 8. We'll do 8 by 6. Then here we'll do inches. We'll do 6.5. See if we can fit everything on here best we can. drivers here. We'll have this here. Then we'll have the screens go in this area. And then we'll have a connector here. We'll put the microcontroller off the board. So look what we're doing. So we're going from this, all that in there. See, it's just loose. I got it screwed to the 3D printed enclosure here. I got these little screens. There's the motor drivers, these three things, and then the PCA, the multiplexers on it. But look at all this. We got all these wires, and we are going to move it to this. So that's what we're going to move it to. We'll go to an actual circuit board, and it'll look a lot cooler once there's actual traces. It's actually OLED, and is it OLED is 0.91 inch, that's what they are. That's it, right there. Right? I see some. What's the pin out? VCC ground. Yeah, that's it. It's actually perfect. So we'll go there. I should have done this from the start. This is how I should have done it before. Okay. So now we just put 5 of these. 1, 2, 3, 4, 5. Oh, I think we're gonna have a problem here. Yeah, because these are gonna sit way too low. So we're gonna have to fix that. I'm gonna have to think about if I should, how I'm gonna raise these up. Oh, I think this is a good time to ask ChatGPT. Right? I'm gonna ask ChatGPT. Hey, I want to place OLED screens on my PCB design, but the problem is that they sit very low on the PCB. I want them to be a lot higher up. What's a good way to offset them?
A simple and effective way is to use pin headers or socket risers. You can solder male pin headers onto the board and then plug the OLED module.
Pin headers. I got pin headers, but I was hoping for a better way.
If you want something more robust or aesthetically pleasing, you could design a custom standoff solution. For example, small PCB standoffs, either prefabricated metal ones or even custom PCB spacers you design, can be inserted between your main board and the OLED module. You'd bolt or screw them in at a fixed height, ensuring a clean, secure, and consistent offset.
I see. So standoffs for the PCB that holds the OLED. So a smaller PCB that holds the OLED.
Exactly. You can design a smaller daughter board specifically for the OLED. That smaller PCB attaches to your main board with those standoffs, lifting the OLED up to the exact height you want. It's modular, stable, and looks clean.
That's a good idea. Okay. Goodbye.
I'm glad that helped.
Yep. Good. Goodbye. All right. I kind of like that idea. What if I make little one board right here? Can I make two? I don't know if I can do this. Is this illegal? Can I do it like this? Huh. Okay, I can. Okay. And then I don't know how to do that. How do I like start XY? Okay. Hold on. Oh, I see what I was doing. Alright, I'm just gonna end it here. I'll get to the routing and everything tomorrow, because before I start routing the PCB, I'm gonna have to route all of this. I'm gonna actually have to make a real schematic. It should be about as the same as something like this, so. Well, that's it. I'm done streaming. Good night. I'm going to start tomorrow. I'm going to finish that up, and then I'm going to tear this. I'm going to tear this apart. Terry, you're tearing me apart. Society. This is society, and I'm going to tear it apart so I can build it back better.